Okay, so hello everyone. Good evening. Okay, so let me share my screen as of now, this moment. Okay, so you can, so we will be discussing for today's topic will be uh, handwritten digit recognition. That means we will write something within our GUI and it will predict that how much it will be accurate the digit. Suppose I've just written here, I'm just writing here the 2. Suppose I'm writing a 2 and it will predict you that if the 2 is how is accurately predicted the value 2. Okay, so this is the thing that we will build. To build this, we will go for keras. We will go for the backend as the keras and TensorFlow with the help of deep learning, something like this. And then we will be and then we will apply this thing, and we will apply this thing for from the GUI. Okay, that means graphical user interface. And we have taken the dataset from MNIST dataset, and from this we will we will be doing from this we will be doing the prediction of the handwritten digit recognition with the help of GUI. Let me tell you the workflow of the GUI. That means first of all we will import the all the libraries. Okay, we will import all the libraries one by one, and then we will go for the dataset to import the dataset to download the dataset again, and then we will train the model and we will build a GUI, that means a graphical user interface will be there, and it will be on the graphical, and it will be, we know that graphical user interface, that means we will build a window or a pop-up. It will show you a pop-up. We will build a window, and then will do we will build our pop-up, and then we will build our window. Then we will just write there any type of data. That means either it can be 2, 1, 9, 8, anything we can do, and then it will predict that how much it will give our accuracy. Okay, so this is the thing, and we will going to build. So let's start with our code. You can see we have, first we will import the keras module. That is, we have written here import keras, and then we have written from keras.dataset import mnist. Mnist means the dataset name. This is the mnist dataset, and we will import the dataset from keras. This is the inbuilt dataset in Python, and this dataset consists of 60,000 data. Okay, 60,000 data of handwritten digits, anything handwritten digits, and we will import this digit from keras. So that we have written from keras dot import mnist. That means whenever we want to collect any type of module, any type of library from any module, then we will obviously all time write from the library, from the module, import that particular library. So that we have written from keras.dataset import mlist. And we know we'll build a neural network. That means we will do a deep learning model. So that we have written here from keras.models import sequential. So that we have written from keras.model import sequential. And we know that whenever we build the ANN or the artificial neural network, we know that uh, the ANN means artificial neural network, or maybe we can do it with CNN or the convolution neural network. Whenever we build the CNN or ANN, it will give us, it will help us to do with our help of sequential. That means our data sequential, it will present on the sequential, and then it will give you some input layer, and then some hidden layers will be there, and then some output layer. Maybe it can be one hidden layer, maybe it can be two hidden layers, maybe it can be three hidden layers. If the hidden layer is going increasing, then our model will also get complex. Okay, so that is the motto. That means whenever we build a neural network, as much as simple we can proceed, it will give you a more accuracy. It will give you a more accuracy. And whenever we do the complex thing, it will give you more complex data sets. Okay. So complete training data sets. So that we have written here from keras.models import sequential. From keras.models import sequential. Then we have written keras.layers. That means from this layer we will import the dense, dropout, and flatten layer. So that we have written here dense, dropout, and flatten. From keras.layers import convolution 2D. That means conv 2D and max pooling 2D. This will help us to build our CNN model very accurately. And then we have written here from keras dot import backend as k. Whenever we use the k, whenever we use the k, that means instead of using backend, we will obviously always write k, nothing else. So this is the thing behind as function. That means from keras import backend as k. So this that's how we can just simply import our libraries, and then we will split our dataset from MNIST data. So we have created a tuple that is xtrain, ytrain, and another tuple will be xtest, ytest, equal to mnis.load data. This load data function helps us to load the data from mnis dataset, and we will obviously, whenever we written here xtrain and ytrain in between a tuple, it will always automatically give an xtrain and ytrain dataset and also be the xtest and ytest in the dataset, and it is from obviously MNIST data. So that's why this tuple has been created, and it will automatically give you 80 and 20%. That means x10 y10 be with the 80% of the data, and x test y test will be the 20% of the whole data set. Okay, so that's how we can just simply build our x-train and y-train. That means our training model. Now, if we just simply check the x-train and y-train, that means how many numbers of rows and columns will be there in between the x-train and y-train, we will simply use the shape function. And how to use that? We know that print of x-train dot shape, comma y-train dot shape. That's it. So it will give us the shape of x-train and y-train. And whenever we just execute the whole code or the import the libraries, whole code, all the things we will just execute, you can see here, it will give you a thing that is downloading data from this, okay, from keras.dataset. So we know that this mnis data is belonging from the keras. We know about that. And you can see the whenever the xtrain.shape, that means the value of the rows of xtrain will be 60,000, 28 and 28. And similarly for prediction, it will be in the 60,000 of the data set. And it will give you a 2s second by step, one by step. We know about that. Okay. So we know that x will be our independent variable and y will be our dependent variable. Okay. So based on the values of the x, we will predict the value of y. Okay. Now we will just change our data set from training and testing. That is xtrain. We have created a variable xtrain equal to xtrain dot reshape. We will be reshaping this data set into use of the with the help of with the help of reshape function. Xtrain dot reshape, xtrain dot shape of 0. That means first value will be there, and we know that Python indexing starts from 0. So that we have written xtrain dot shape of 0, comma 28, 28, and 1. This is the 28 to 20 it will be there, and we know that xtrain will be unique value, so that's why we have written here 1. Similarly for xtest, that xtest dot reshape, xtrain dot shape is 0, 28, 28, comma 1. And we know that input shape will be obviously 28, comma 28, comma 1, because we know xtrain and xtest will be consist of 28 and 1. Okay, so this is that xtrain and xtest, and obviously the input shape of the xtrain and ytrain of the model, rather than we will say that input shape of the model. Now we will convert the ytrain, or the convert the values of y. We will convert the values of y into the binary classification of the binary matrices. We know that. So that we have written xtrain equal to keras dot utilis keras dot utils dot to categorical y-trend. So these are categorical value. So this is the conversion of the categorical variable from 0 to 1. We know that. That is, it is we why the categorical variable needs to us, because we know that the value will be predicted as either 1 or 2 or 3. So that's why we will convert the categorical variable to 0 and 1, binary classification. Okay, so binary classification vectors, we will just convert the whole thing. So that we have written y-trend equal to keras dot utils dot to categorical y-trend, and similarly for y-test equal to keras dot utils dot to categorical y-test. So there are two matrices, one is y-trend and y-test, the two matrices. And similarly, we will convert this xtrend, that y-trend equal to xtrend dot as of type float 32, and we know that xtest dot as type will be float 32. So the two variables will be there, xtrend and y-test, and we will convert this xtrend and y-trend to these variables. And we know that whenever the digit will be written, it will be in the format of the black and white, that means grayscale format. So that's why we have written xtrend equal to xtrend divided by 255. Here you can see xtrend backslash equal to 255. It means xtrend equal to xtrend, whatever the value of the xtrend will be, it should be divided by 255 range. We know that 0 will be for black and 255 will be for white. So that's why we have to divide the whole thing by 255. Similarly for xtend and similarly for y, similarly for xtest. Some things will be there. Now, whenever we check the print of xtend shape, that is xtend dot shape, it will give you the 60,000, 28, 28, and 1. And for xtrain dot shape will be 0. That means this is the indexing part of the xtrain, and similarly for this is the indexing part of the xtest. It will give you 60,000 and 10,000 test samples. So we have written that the 60,000 data is for training purposes, and 10,000 data is for test purposes. So that we have written 60,000 train samples and 10,000 train test samples. So this type of two categories will be there for xtrain and y-test. And we know whenever we use the convolution 2D, that means CNN, we have to specify the batch size. We know that. So batch size equal to 1 to 8. Num class is equal to 10 and epochs will be 10. Okay. So batch sizes will be 128, num classes will be 10, and epochs will be 10. So 10 epochs will be there in each and every batch. Now Now we have defining a model variable, that this is our variable model equal to sequential. We have created an object of the sequential library, that is model equal to sequential. Then model dot add conf 2D, that means convolution 2D 32 comma kernel size would be 3 comma 3. We know that 3 cross 3 3D diagram will be there. So we have to specify the kernel size, that is 3 comma 3. And activation should be relu. We can use softmax, we can use it. Okay, we can use it tanh, anything, but we'll always prefer to use the relu function. Input shape will be our input shape that we have already defined. Okay, now we will use the model dot add count 2D. 64 will be our value that we have written already. 64 comma 3 comma 3, that means 3 cross 3 matrices will be there, and activation should be used in relu. And for model dot add max pooling 2D, pool size should be 2 comma 2. That means 2 cross 2 should be our pool size. We know from the CNN that whenever we use our kernel, whenever we use the max pooling, whenever we use the whatever we say dropout, whenever we will use the uh, flatten layer, we have it will automatically decreasing, because from that particular matrix 3 by 3, maybe 4 by 4, anything you can take. So from these matrices we will have to put a mapping to the other matrices. So value of the that's why the value of the what will say value of the matrices will decrease. Okay, so the max pooling 2D will be pool size equal to 2 comma 2. Now we have written model dot add dropout equal to 25%. dropout should be in the 1/4 of the whole thing, that is 25%. We have used model.add flatten, so we have used the flatten layer, model.add flatten, and model.add dense equal to 256. Then because the density of the complex model is 256, so that's why we have used dense equal to 256, and activation be the rel. We can use also the tanish, we can use also the software function, anything we can use, but most of the time we will prefer to use the relu function. Model.add dropout equal to 0.5. Model.add dropout equal to 0.5. Now model.add dense num classes and num classes that we have already defined in the previous part, that is num classes will be there, and our activation should be softmax, because in the whenever we try to predict something, we will always prefer to use the activation function as softmax. Okay, now we'll have to all define all add the kernel. We have used the max pooling, we have used the flatten layer, we have used the dense function, we have used the dropout function. All the we have created an object for sequential in the first. Okay, so all the things we have already built up. Now we have to use the compile function. Now you have to use the compile. You can see whenever we use the add function, whenever we use the max pooling, whenever we use the dense function, dropout function, we always try to use the compile. That means model.compile, because we know that whenever we use all the things, it should be we have to compile all the. So that's why we have written model.compile. Here compile will be our function, and loss equal to keras.losses dot categorical cross entropy. Optimizer equal to keras.optimize. Adder delta and matrices will be accurate. This will be accurate whenever it is run their epochs, it will print the value of the particular matrices, and also it will give you the categorical loss. It will give you the categorical loss from the keras.losses. We have written here loss equal to keras.losses give you how many losses will be there. So that's why it will give you the loss in keras. Okay. Now we will create. So we have already compiled all the models. So our model is ready for training. Our model is ready for training. So to train our model in CNN, NN, ML, anything, we will use the fit function. So that we have created an object of the variable hist equal to model.fit xtrain comma ytrain. So we have fit our model in the xtrain and ytrain. Batch size equal to batch size that we have already defined. That is something like 128. Batch size our 128. That means in each batch 128 values will be get epoched. Okay, so that's why we have written batch size equal to 128. Maybe it will be batch size, and epochs equal to epoch. So this is our function name, epoch equal to epochs. Verbose equal to 1. That means one will be our unique value, and validation data. That means in our whenever we train our data set, we know that we will split our data set 80% of the training and 20% of the testing data set. We know that, and whenever we will execute our validation of that particular data, we will apply that model in the X test as well as in the Y test. So this is the thing. For validation of the data will be X test from a Y test. After build our model, we will have to something like print the model has successfully trained. After training of the training purposes of the hist in our model, it will give you the model has successfully trained, and we'll save the model, that is model.save mnews.h5, and we will print saving the model as mnews.h5. That's it. So that's how we can simply print our model. Simply, we can simply print our model. We can simply save our model. Now let's check what epoch and what our losses, what our accuracy value should be. We know that epochs will be with the classes of 10. Now let's check. You can see. So first epoch. That means 1 by 10. 1 out of 10 epochs will be there. First epoch will be here, and you can see 469 values will be there to train, and it will take time 87 seconds at the 87 seconds, 17 microseconds it takes time. That means near about 1.5 minutes to train all the values. You can see losses should be 2%. That means 2% loss occurred here, and accuracy is 15%, and value loss will be our 2.2%, and value accuracy will be variable. Immediate accuracy would be our 35%. Okay, so this is the thing. This is the 25, 22%. This is the 15%, and for this we will ultimately taking the val accuracy, that is variable value accuracy, that is 35%. Okay, now whenever epoch 2 is going, you can see this variable accuracy is getting changed. That means it is getting changed from 35% to 56%, near about 57%. Okay, so this is from 35% to 57%. It is changing, and the loss should be minimum. You can see 22.8% loss in the first epoch, and you can see 22. That means loss is gets increased in this second epoch. Similarly, for epoch 3, the accuracy is going up. That is 66%, and it will take more than, I mean, more than, not more than, it will take near about 1.5 minutes. That is 84 seconds, 180 microseconds, and accuracy should be 41% from 28%, and our value accuracy will be increasing to 66% from 57%. Okay, so this is the number 3 by 10 epochs. You can see 10 by 10 will be there. 10 by 10, that means after finishing all the epochs, it will print out similarly, it will print out the model, that the model is successfully trained, and our accuracy will be 83%. This is huge. That means our accuracy will be our 83% after success training of the data set, that is with the help of fit model. Okay, and we have also, after compilation, after all the things, it will give you the print the model has successfully trained, and saving the model as mnis.h5. You can see the model has successfully trained and saving the model as mnis.h5. Now we will check our accuracy. You can see we have our, what we'll see, this is our object score equal to model.evaluate x test by test, variables will be 0, and the print of test loss should be score of 0, and test accuracy should be score of 1. So our loss will be near about 80%. Our accuracy will be 83%, near about 83%. That means whenever we predict some values of the handwritten digit, it will give you a prediction of 83%. And this is our motif of the thing, and the loss should be 80, near about 80%. Okay. Now this is we know about the accuracy, but we have to predict the thing. So that's why we will build a GUI, that means graphical user interface. So how to build that? Let's check. So we will use from keras.models import load model, from kinter import star. This from kinter import star, we know that this star means we will extract all the libraries from kinter with the help of this star. From kinter import star. From kinter import import kinter stk, import win3 to GUI, import PIL, from PIL import image grab, and also image, and numpy as np. So we have already import numpy, PIL, WinGUI, and kinter, and dot models. Then from models it will be in the load model. So all the libraries, necessary libraries, we have extracted, and we will load our model data set. You can see the data set in the presence of sequential data. So that we have written keras.engine sequential. We know about that. This is the data of the sequential data. That means our mnis.h5 data is in the format of sequential. Now we will build our GUI, that means graphical user interface. To build our graphical user interface, first of all, we will just simply uh, now first of all let me check my um, output. Then we will build our data set. You can see this is our output. That means this is our output. We know that. Now here we will just simply draw our data set, and it will give you the thinking image, that is use whatever we use to predict the handwritten recognition digit. It will be give you the output in this particular function, and it is our clear button. It will give you the clear button, and it will be our recognize button. So we have to give the functionality of the two what will say of the two button. Will give you it will give you the two functions of the given button. So let's check one by one. So this is our purpose to build our GUI. That means this is our uh, output sources. Now let's check how to do that. So first of all, we will define an image. Sorry, define an what will say function. Def predict digit. So this is a function name. This is a parameter img, and we are resizing this image img equal to img dot resize 28 comma 28. So this is our pixel. That means we will this is our 28 pixel to 28 pixel. This is our overall what will say overall our images. This size of the images. We will convert this images to the grayscale, that is RGB to grayscale. We will just simply convert this. So to convert this, we will use the function convert function image dot convert L. That means this is our in the format of the grayscale function, and we will convert this image whenever it will be in the conversion of the grayscale image. That means 0101. It will we have to we this is our necessary duty to convert the image into the numpy. So that's why we have written numpy, that means np.array image. So we'll convert this image to the numpy array. Now we will again reshaping that value, that is image.reshape 1, 28, 28, 1. And we will update our image value, that is image equal to image divided by 255.0. This is our float value. So that's why we have written 255.0. We simply reshaping the value from 60 to 1. So that's why this reshaping of the model is occurring. Now we know that from the first value we have to create our model. So that's why we take our value that we know that Python indexing starts from 0. So that's why we have written res equal to model dot predict image of 0. That means first image will be there. From the first image we have to predict that, and return np dot argument maximum res comma maximum of res. We know that from np, that means numpy, we will have to use the argument argmax function of the res and maximum of res. That's it. Now we'll define a class. So to going into the class, we know that anything we can define as a function like class, and we will create to call the class. We know that whenever the function call is happening, so there will be a function call. Like the function call happens, that means there will be a situation that will create a variable and call that. So that's why that is how we can create an instance to that particular class, and we know that from this particular class will simply extract our answer, maybe inheritance, anything we can do. Now, so that's why we have defining a class, that is class tk.tk. So this is a function name tk function. Okay, we will build a constructor, that is def underscore underscore init underscore underscore self. So this is our constructor name, and we know that whenever we use this constructor, we have to pass a automatic parameter, that is, and we use this parameter. We use the tk dot double underscore init double underscore self. That means self used by tk, and we know that set dot y equal to 0. That means that's how we can use the self function set dot x set dot y equal to 0. Now we will create any type element, that is self dot canvas equal to tk dot canvas self comma width equal to 300, height equal to 300. Background will cursor equal to cross. That means whenever we press the cross button, it will get cross. Okay, it will be cross, and background will be white. Whenever we use the foreground color, it will give you the color as the letters of the colors. Okay, background color will be white. Self dot label equal to tk dot label, self comma text equal to thinking. Things should be there. The two buttons will be there also. So the text will be. Know that whenever we use the label function, we have to use the text function. Okay, font equal to Helvetica and 48 our font label. Okay, so we can use them. Now self dot classify button, that means two buttons will be there. Ticket dot button self text equal to recognize. One button is for recognize, we know that. One button recognize, another button is for clear. So text equal to recognize, command equal to self dot classify handwritten. Just a moment, let me, yes. So classify, self dot classify handwriting, and self dot button clear. So the clear button will be present there. Ticket dot button self comma text equal to clear, command equal to self dot clear all. Whenever we use the clear button, it will get clear. So that's why we use the clear all function. Now we will use, now we just simply maximize the value. This portion will be there in the whole page. So we have self dot, we have to use the canvas function to to give their proper to give their proper, what we'll say, to give their proper distance or to give their proper position. Things that is, one is our recognition, one is our canvas function. That means whenever we draw there, and the two buttons. Okay, so that we have written self dot canvas dot grid equal to 0, column equal to 0, pad equal to 2, and sticky equal to, that means in the west position it will get sticked. This is the west, this is east, this is west, this is east, this is north, and this is south in the GUI. So that we have written sticky equal to W. Self dot label dot grid row equal to 0, column equal to 1, pad equal to 2, pad x equal to y. So 2. So the pad y will be 2 and pad x will be 2. So and the row will be 0 and column will be 1. So label function, you know that. So this is the row 0 and column 1 for the thinking. Now we have to use the two buttons. One is self dot classify button dot grid row equal to 1, column equal to 1, pad will be 2, and for x 2. And similarly self dot button clear button dot grid row equal to 1, column equal to 0, pad y will be 2. So that's the thing of the grid structure. Now okay, now we'll use to bind all the things, that is self dot canvas dot bind. So the one motion will be done, self dot draw lines will be there, and lastly we have to use the another function, that is our clear all function, def dot clear all self. So self dot canvas dot delete, all the things will get deleted in the, whenever we press the clear all button, because whenever we use the clear whenever we press clear button, it will hit directly to the function and it will get deleted all. Classifying handwriting. So we have to use the self function automatic parameter, and we have already created an object, that is hwnd equal to self dot canvas dot winfo id. Okay, so we can handle properly our canvas. We have used winfo id, and for to coordinate with the canvas, we will use the function, that is WinGUI and get window react. That means and we'll store this variable, all the things we get with the function in the rect variable. So rect equal to win30 dot get window rect hn hwd. This is our object we have passed through. And lastly, m equal to image grab dot grab react. That's it. So that's how this rect and this hwnd variable gets connected by this get window react. Okay, by the coordination of the canvas. Okay, so we have created three objects. One is 80, rect, and I'm. Okay, so this is the thing, the classify handwriting function. Now there will be two variables. One is digit, another is ACC, and we use the predict digit IM. It will give you the one is digit and for ACC. Okay, so the two things will be there, and we will use the label function set.label.configure text equal to string of digit plus this is the concatenation of the string, so that's why we have written string of digit plus string of integer of account into 100 plus percentage. Okay, that means how many percentage it will get predicted accurately. It will give you the configuration of the particular this configure string. Now we have to use the canvas to draw the things. This is our draw the things, so that we have read def draw lines self comma event. This is our event function, and we have to use this event function by the help of this self function, so that we have written self.x equal to event.x, and similarly self.y equal to event.y. R equal to, we have set a variable r equal to 8. Now self.canvas dot create oval, the function that oval type things will be there. Self.x minus r, self.y minus r. That means it is reshaping all the things. Self.x plus r, self.y plus r, and fill will be in the. That means it is in the particular case of the what will say black digits. Black color digits will be there. We have to fill the things. Okay, so this is self.x minus r, self.y minus r, self.x plus r, and self.y plus r. It will give you all the reshaping functions. Okay, all the reshaping functions with the help of this create oval, and this create oval is getting from the canvas. And as we are going to use this canvas in this class, or rather than this function, we have to use the self function. This self.canvas create oval. And now we will create an object of the app, that is app equal to this app, and whenever we want to visualize the thing of the GUI, we know that we have to use the main loop function. So that's why we have written main loop. And here you can see this app is declared. This app is declared. So that's why first we have to call the class, that is app class, and we have to call this class with the help of this object. This is called the object, and we have to use the main loop function, because otherwise it will not going to show anything for the uh, handwritten declaration. But we have used the app equal to app function to call the class, and this is our object, this is our class. We know from this is our class name, app, this is our class name, and we will call our object, that is app equal to, and we will similarly do the main loop function. Whenever we use the main loop function, or rather than anything, one of the things, it will give you a pop-up like this. It will give you up like this. In this pop-up, you can see this is the white shed, and this is the that we have already written here. You can see the thinking text will be, so the thinking text has come. Now just you can minimize this. Just a moment. Okay, so the two things will be there. One is our thinking. This width, you can see width equal to 300, height equal to 300. So that's why this comes. And we have written our recognized text, that is this is a recognized text, this is a clear text. See there. And whenever we use the command, that means this is our function called set clear or set classify handwritten anything. So this is our what we say, this is our function called. So this is how we can simply, that's how we can simply build a GUI. And with this GUI, handwritten recognition. Let me give an example that will help you. Okay, so let me give you another example. That is, I have written already two here. In the previous, recognized will be two will be 51%, near about 50%, 52%. And again, if I just simply run that thing, you can see this is a thinking button. And suppose I have written here three. Let me check with three. You can see this is our three. This is our three, and I want to recognize this. You can see, okay, two. This is two. This is quite like this type of things will be there. That's why this two comes with the low accuracy. That is 46%. Okay. So let me check one thing another. That is let me check with not five. It will be in the seven. Let me check with seven. It may be like that too. Okay. So let me check again. Seven. I think it will be get again two because this type of things will be there for two. Okay. So that's why the two is coming. But also here you can see with the accuracy of the 47%, that is very much low. That means this 2 is not predicting correctly. Okay, this is the low accuracy 2 prediction, and it will get high chances rather than 2. It will get high chances rather than any value of the any value instead of 2. Let me again recognize the 2, and it will give a proper 2. I think this is 56%. Okay, the accuracy should be because some hand because this type of digits whenever we write this type of digits whenever we not write rather than whenever we just draw our digits it should be proper. Okay, so that's why the accuracy should be gets maximized. Okay, let me check once again. That is clear. Let me check once again. That is 2 should be proper. Let me check. So okay, let me record this. You can see 47%. That is quite different from 56 or 46%. That's how we can simply predict our this is the concept. So that's how we can simply predict our handwritten digit recognition. Okay, so we can draw any type of data and it will just simply predict that. Okay, it will just simply predict that variable that which data you have written there. Okay, so with the help of this GUI and with the help of these neural networks, that means this type of max pooling 2D, this type of flattened layer, this type of convolution 2D, or whenever it will get maximum, it will get mixed, it will give you a proper accuracy. That is maybe 56%, 56%. It is enough for that. Okay, this is enough for that because we are drawing that part. We're drawing that part. That is it two? Is it one? Is it seven? So that this is the thing. Okay, so this is the thing. This is all about today. So again I'm telling you, we have used the convolution 2D, the flattened layer, dense layer. Okay, from the back end of the keras and sequential, we have already built up, and after build up the model, we will simply put that model into GUI. That means graphical user interface, and there will be two buttons. Will be one will be clear, another will be recognized, and there will be two interfaces. One is our output interface, another is our input interface. In the input interface, we will just simply draw our data. We will simply draw our digit, and it will get present. It will be predicted by our model. Is it two? Is it one? Is it seven? Anything? It will just simply predict that. and after that it will give you a proper percentage. That means this could be 2 with 87%, this could be 2 with 56%. So that's how we can simply build up our data set. We have built our GUI or our handwritten digit recognition. Okay, so this is the thing for today. Hope you guys enjoyed. Thank you for listening. Thank you everyone.